we are going to review how to simplify radicals. When you take the square root of 25, what you are really asking is what number multiplied by itself gives you 25. That number is 5. That's why the answer of the square root of 25 is 5. If I ask you what is the square root of 16, what number multiplied by itself gives you 16 is 4. Now, there are numbers that they don't have a whole number as a square root, but we can simplify. Let's look at number 50. The square root of 50, to simplify radicals, we need to rewrite this number as the prime factorization. Let's review. Okay, 50 is 2 times 25, and 25 is 5 times 5. Prime, prime, prime. So when you take the square root of 50, it's taking the square root of 2 times 5 times 5. You are going to look for a pair of identical factors. Two numbers that are exactly the same that are multiplying. Here we have 5 times 5. These are identical factors. So what is the simplification of this square root? Any number that has a partner gets out, and a number that doesn't have a partner stays in the radical. So if I want to write the simplified square root of 50, this would be 5 square root of 2. Now, let's start with the examples. Let's practice more. Let's look for the square root of 32. This is not a perfect squares. I cannot find two numbers that give me 32. 6 times 6 is 36. 5 times 5 is 25. So there is not a whole number multiplied by itself that give me 32. So I need to simplify. Let's break down 32. 32 is 8 times 4. Good. 8 is 2 times 4. 2 is prime. 4 is 2 times 2. Prime, prime. And 4 is 2 times 2. So how many 2's do we have? 1, 2, 3, 4, 5 2's. I am going to write the expanded forms. This is 2 times 2 times 2, 5 times. Now, I am going to make groups of 2 of identical numbers. Here I have one group, another group. For each pair, one number gets out. So there is a 2 going out, multiplied by another 2 that is going out also, that is exiting the radical. And inside the radical, a number 2 stays. So what is the final answer? 4 square root of 2. So the simplified radical for square root of 32 is 4 times square root of 2. So let's call this example 1. Let's do another example. Let's go and simplify the square root of 200. Okay, 200. Let's find the prime factorization. This is 2 times 100. 2 is prime. 100 is 10 times 10. 10 is 2 times 5. And they are prime. So when I write the prime factorization of 200 is the square root of 1, 2, 3 2's and 2, 5. Groups of 2. Here there is a group of identical factors. Identical factors. So this 2 that has a partner gets out. From this pair of 5, 1 5 goes out. So I have 2 times 5. And the lonely one, the one that doesn't have a partner, stays inside the radical. 2 times 5 is 10. 10 is square root of 2. Okay, so this is my example 2. Let's give a fair example. the square root of 75. Okay, 75 is not a perfect square, but any number, remember, that ends on 5 can be divided by 5. Okay, 5 times 15 give me 75. 5 is prime, and 15 is 3 prime. 3 times 5. So the square root of 75 is 3 times 5 times 5. Can I have a pair of identical factors? Yes. Here it is, 5 times 5. So there is a 5 going out, and there is a 3 inside. So the square root of 75 is 5 square root of 3. So this was my example 3. Now I want to give you an example where you cannot simplify. Example, here it comes. The square root of 26. Let's break down 26. 26 is 2 times 13. 2 is prime, 13 is prime, so 26 is 2 times 13. There is no partner. Nothing. There is no number that can get out. So this is just the square root of 26. It cannot be simplified.